All right, so we're going to talk about CPCTC proofs, this one involving an isosceles triangle. As a reminder, CPCTC stands for corresponding parts of congruent triangles are congruent. So, when we are trying to prove that segments or angles are congruent, we first want to prove that the triangles that they are in are congruent. That then allows us to talk about the pieces. The example in this video, we're going to prove that the angle bisector of the vertex of an isosceles triangle is also the segment bisector of the base. Our first step is always to rewrite the thing we want to prove into if-then form so we can identify the hypothesis and conclusion. In if-then form, this statement says if a line bisects the vertex of an isosceles triangle, then that line also bisects the base of that triangle. The hypothesis here is a line bisects the vertex of an isosceles triangle. The conclusion is that that same line bisects the base of the triangle. It's also valuable to identify some important vocabulary here. So isosceles triangle is a triangle with two congruent sides. Those two congruent sides are called legs. The vertex of an isosceles triangle is the angle that connects those two legs, the two congruent sides. The base of an isosceles triangle is the side that is not congruent to the two legs. So in this theorem, we're saying that we have a line bisecting the vertex, this angle between the legs, and claiming that it also bisects the base, which is the side between the legs. Setting up the proof. Here's our theorem again. If a line bisects the vertex of an isosceles triangle, then that line also bisects the base of that triangle. Our hypothesis is that a line bisects the vertex of an isosceles triangle. We've actually got a couple different pieces of information we can get from this. So our first piece of given information from this hypothesis is that we have an isosceles triangle. The hypothesis doesn't name it for us. We're going to go ahead and give it a name. We'll call it triangle ABC, and we'll say that the base is AC. So AC is the side that's not congruent to the other two. Here's a picture. We also know that we have a bisector of the vertex angle. Vertex angle is angle ABC, so we're going to call that bisector BD, and we'll draw it in here. And if it bisects the vertex, that means that those two angles up at the top, ABD and CBD, are congruent. A conclusion in this theorem is that the line bisects the base of the triangle. That means that we want to prove that BD bisects AC. So again, our given information is that ABC is an isosceles triangle with base AC, and BD bisects the vertex angle ABC. Our goal is to prove that BD bisects AC. So let's get started. Always start off with our given information. We've got two pieces of given information. First one, ABC is an isosceles triangle with base AC. Because it's an isosceles triangle, we know that isosceles triangles have two sides congruent. So we can say that AB is congruent to BC by the definition of an isosceles triangle. That's about as far as we can go with that. So we'll grab our second piece of given information, which says that BD bisects angle ABC. We know that bisectors cut things in half. So that tells us that angle ABD is congruent to angle CBD by the definition of a bisector. That's about as far as we can go with that. We've only got two pieces of information about these triangles so far. We need three to prove that triangles are congruent, but we've also got a shared side. So we can say that BD is congruent to BD by the reflexive property. Then we have a congruent side from the legs of the triangle. We have a congruent side from the reflexive property, and we have a congruent angle connecting those sides from our angle bisector. Therefore, we can say that triangle ABD is congruent to triangle CBD by side angle side congruence. Once we know that, we can look at our triangles and say, hey, AD and CD match up in the names of these two triangles. So AD is congruent to CD by CPCTC. And since bisectors cut things in half, and we've just said, hey, those are the same length, we can say that BD bisects AC by the definition of a segment bisector. The end.